couple acts on each of the handles of the mini-dual valve determine the magnitude and coordinate direction angles of the resultant couple moment. Okay, so we have two valves here, two handles here, and so here's our XYZ system, X, Y, and Z. And couple moments are applied here on the left-hand side. Handle at 35 Newton force couple is applied, and on the right-hand side, handle at 25 Newton force couple is applied. And the diameters of the handles are both 350 millimeters, and that will be equal to 0.35 meters. Okay, that's the diameter of the handles. So we are asked to determine the magnitude and coordinate direction angles of the resultant couple moment. Okay, so here we can find the mx x component of the resultant moment couple and the y component of the couple. Notice that the moment vectors, they pass through the components of the moment vector, resultant moment vector, x and y. They pass through x-axis and y-axis, and there's no z-axis component. So here we find the x component of the resultant moment vector, and that would be, this is 35 times 0.35, the moment caused by this handle, and it's the vectors points towards the minus x-axis because the rotation is this way. So that's the rotation, the sense of the rotation. So if you apply the right hand rule, you will notice that the x component of the vector, moment vector, that's the moment x, is pointing towards the minus x-axis. On the other hand, this handle, 25 Newton force couple, has a tendency to rotate this handle in this direction. And if you obviously we need to find the components of this force vector, but you can feel that it's also pointing towards the minus y-axis. So that is, if you like, I'm showing with two arrows the moment vector. So that is like moment caused by the second handle. Okay, so that's the first and that's the second handle. So we're going to be finding the x component, and the y component of this vector, essentially, and then use both for the determination of the resultant couple moment. So mx, for mx I'm having minus 35 Newton and times 0.35 meters. Okay, so that's that. And on the other hand, I have the x component of the moment caused by the second handle, so that's that. Okay, and it's essentially moment y, 25 times, that's minus 25 Newton times 0.35, that's the diameter. Okay, meter, but cosine 60, that's cosine 6 degree, because I want the x-axis component. Right, so this gives me a moment x value of minus 16.625 Newton meters. Okay, as for the moment y, I will be only having the y component of this moment vector caused by 25 times 0.35. So the force couple 25 Newton times the distance between the force couple, and that's 0.35. So that's my moment, and this is my, by multiplying this by sine 60, I'm going to be finding, so that's 60 degree, so sine 60 will be this, and that's minus, it's pointing towards minus y-axis, and that is and that will be equal to, I'm going to be having moment y equals minus 7.57 Newton meter. Okay, so the magnitude of that, magnitude of the resultant would be square root of moment x plus square root of the squares of mx and my. Okay, plus minus 757 squared, and that gives me 18.3 Newton meter. Okay, and for the direction angles, or the direct coordinate direction angles, but that's the coordinate direction angles. So the angle that the moment, resultant moment, makes with the x-axis is arc cosine of the x component, minus 16. Okay, so that's minus 16.625 over the magnitude of the resultant vector, which is 18.3, and this gives me alpha equals 155 degree. And for beta, I will have cosine, arc cosine, right, and 7.57 over 18.3, and I find here beta to be 115 degree, and for the gamma I will have cosine, arc cosine, so my results and my component value, magnitude of the z component is 0, there is no z component, 18.3, and that's 90 degree. This is what I expect to find actually for the gamma angle. Okay, so this is my magnitude of the resultant couple moments, and these are alpha, beta, and gamma values, the coordinate direction angles, and that concludes the solution of this problem. And thank you for listening.